This week's episode is featuring OmniPro. OmniPro can be added to any spray mixture to enhance plant uptake of organic crop protection products. Visit stbiologicals.com to learn more about this and other regenerative ag products. Hello and welcome to ST Biologicals Soil Speaks podcast. This week, we'll explain oxygen's role in the carbon cycle. Let's get started. We breathe in oxygen that plants have generated. We are dependent on the plant world for our very survival. Plants also need oxygen to survive. How do we make sure there's enough oxygen for non-plants and plants for optimum health? We start by making sure all parts of the carbon cycle are functioning efficiently. The carbon cycle is circular. It starts with photosynthesis, then plant respiration, and ends back at photosynthesis. Within this cycle, plants use oxygen in processes that create organic compounds: water, carbon dioxide, and the oxygen we breathe. Some compounds influence the structure and function of many molecules and determine the health of your crop. They affect cell elongation, germination, and seed set, and create organic compounds. When a plant is healthy, these organic compounds protect it from pests and diseases. Oxygen is the catalyst for converting the glucose created by photosynthesis into an energy form usable by plants. Oxygen is expelled from plants as a byproduct of photosynthesis, along with water. Plants supply the oxygen that we breathe, and they create rain, given the right conditions. You may not want a chemistry lesson, so the short story is that without the right amount of oxygen, photosynthesis isn't very effective. Your crops will be stunted and your yield low. Carbon and oxygen go hand in hand in creating healthy plants. Photosynthesis is the breathing in of plants. Respiration is the breathing out. Sunlight in the presence of oxygen and carbon creates glucose, oxygen, and water vapor in plants. Plants get rid of the waste products of photosynthesis through respiration. Those waste products are water and excessive oxygen. The plant creates energy. Plants also respire carbon dioxide, but the net result is that carbon and oxygen are stable, and there's more oxygen for non-plants, like us, to breathe. The biological, chemical, and physical structure of your plants and the soil are interconnected. When there is any kind of stress on plants, drought, nutrient deficiency, or waterlogging, the process of photosynthesis and respiration are less efficient. High temperatures and drought affect how your plants breathe through small openings on the undersides of leaves. Plants want to retain water in these stressful situations, so these openings only open up for a short period of time. That means there can be a buildup of oxygen in the form of reactive oxygen species that are toxic to plants and can cause a great deal of damage. The physical characteristics of your soil determine how much oxygen is available to roots for uptake and growth. Photosynthesis isn't the only way plants obtain oxygen. The soil structure, whether compacted clay or sandy, is a determinant in optimum crop growth. Those soil characteristics affect the oxygen available to the plant roots. When you drive farm equipment over your fields, you're creating compaction. If you also have clay soil, this can be a serious problem. When plant roots don't get enough oxygen, they take in less water and nutrients. The lack of oxygen impacts how much of the sugar created through photosynthesis plants can use. Lack of oxygen affects a plant's efficiency, growth rate, and yield. Sandy soils have large soil particles, and there's plenty of space for oxygen. But plants need a balanced environment, and multiple factors go into optimum plant health. Water is a common limiting factor in sandy soil. Adding organic matter in the form of cover crops and manures can begin to alleviate issues associated with both clay and sandy soils. Cover crops used with a no-till system can decrease compaction for stronger root systems. Plant respiration occurs both from leaves and roots. The openings on the underside of leaves open and close to allow oxygen to enter and carbon dioxide to exit. Yes, plants need oxygen to fuel metabolic processes, but they also need carbon dioxide. Root hairs increase the area for exchange of all gases, including oxygen, to the soil. But this can only happen if the soil has enough air spaces to absorb the oxygen. An optimum oxygen supply to the root zone increases root development, so plants can absorb more water and nutrients. Your crops will perform poorly if the soil is compacted, without pore space for oxygen molecules. The use of intensive tilling and synthetic fertilizers has a detrimental impact on soil health. It leads to compaction, salinization, and loss of life in the soil that creates pockets for root development. Oxygen in short supply in many cultivated fields. Tilling increases the oxygen content of a field in the short term, but at the expense of long-term soil health. When the soil is out of balance, whether from too little or too much of a nutrient, plants cannot achieve their optimum potential. Most plant problems are caused by environmental stress, sometimes from extreme weather, and sometimes from agricultural practices. At ST Biologicals, our mentors can help you improve the balance, oxygen flow, and ROI at your operation. Visit us at stbiologicals.com to learn more. When soil speaks, we listen. Thanks for listening, and we'll catch you on the next one.